All right, hi everybody. So I'm going to go ahead and apologize that I am not a professional streamer. I have never in my life recorded anything with a webcam until this exact moment. So this is probably going to be pretty rocky for a little bit, so just kind of bear with me. So what we're going to do right now is we're going to go through the process of creating a very, very simple 5-function calculator with C# and .NET. And this is going to be sort of a primer that encapsulates a lot of the very rudimentary sort of syntax we've been talking about over the last two videos. So in the fall of 2019, we started this course, and I was very heavy on going through every line of syntax and explaining for loops as if people had never seen a for loop before. The feedback from that was that people who take 4,000 levels computer science classes are not stupid, and we should probably just sort of go on to the next thing. So this is basically a very quick and dirty way of doing that. So we're going to go over the highlights now, make a really kind of rudimentary calculator, and then talk about ways that we can make it better with encapsulation. So first of all, what I want to do is I want to talk a little bit about what a workload is. So in the walkthrough of Visual Studio for both PC and for Mac, I alluded to the fact that you needed the .NET desktop development and the web development workload. If you go into your Visual Studio to Tools and then Get Tools and Features, what will happen is a box like this will pop up. These are all of the different workloads that you could possibly install. There are specific things for Python and Node.js and whatever. For this course, the two that you absolutely need are ASP.NET and web development, which is this top left one, and .NET desktop development, which is where we're going to start the course. So as we go through the rest of the class, there's going to be a need for data storage and processing. This will make your life a little bit easier, but like I said, you can always come back in here and add whatever you need whenever you need it. So we can make sure that these things are checked, and in my case they are, so I can go ahead and close this out. So that brings us back to our happy hello world kind of code example. So the first thing is that the syntax highlighting in Visual Studio is fairly good. So if you see things that are underlined in red squiggles, that usually means that something untoward has happened, and if you right click on it, it will tell you a way to potentially do it better. And also you see these using statements up here. These are importing or referencing libraries that I'm not actually making use of. And so if you see the little light bulb right here, if you hover over them, if you click the light bulb, it will tell you, hey, these things are unnecessary, you may want to remove them. And so I can remove them, and now everything is kind of happy. And if you see in the bottom left, I have a green check mark indicating that no issues have been found with this sort of style of my program. So we're going to save that. And so now what we want to do really quickly is go through the process of allowing a person to input some numbers, maybe add those numbers, subtract those numbers, divide them, multiply them, take the square root or whatever. So how we're going to do that first is with just a bunch of if statements or switch statements, and so we'll walk through that first. So first of all, what we want to do is make use of this same right line situation, and so we can say welcome to my calculator, something kind of hooky. Then we can have the user select an operation. So here what we want to do is just allow them to specify one of the, let's call it 4 operations. So first would be addition, the second one would be subtraction, the third one would be multiplication, fourth one would be division, and then we can do a fifth one, which is square root. Okay, so that's quite a lot of console.writeLine statements. So the first thing we're going to talk about is string interpolation, which makes this a little bit easier of a situation. So you obviously could just use the /n character to do this. So we could say /n and then /n and then /n and /n and /n. And this will do exactly the same thing as our fairly verbose sort of 5 additional lines of console.writeLine will do. So this is exactly as you would expect. The /n is just a new line character, and when you print this thing to the console, it will print please select an operation followed by addition, subtraction, multiplication, division, square root, all on different lines. So you can see that this is fairly long. Another thing that you can do is split the line. And so now what has happened is this has concatenated the two lines together with a plus symbol. So C# is smart enough to know that this thing is a string, this thing is a string, and it allows you to break the line with the writeLine method. So here this will print exactly the same thing, except now you can actually see all of it instead of it going kind of off the screen. So if we run that up, we get what we kind of expect. Welcome to the calculator, please select an operation, 1 through 5, and then we're waiting for some user input. So now what we need to do is figure out how to be clever with this user input. So what we want to do is something like this. So we talked about the var keyword previously. So what var is going to do is it's going to infer from the right-hand side what the type of selected op should be. And in this case, you can see from the hover over that read line actually returns a string value. And so this selected operation is going to be a string, even though it's a numerical value. It doesn't really matter. You could cast it if you wanted to, but it's going to come over as a string by default. So what we could do next is do a bunch of if statements. So if selected op dot equals 1, do some stuff, else if selected op dot equals 2, do some more stuff, and then just take that's going to be 3, 4, 5, and then we could do another console.readline down here. So this console.readline is just going to pause the terminal so that we don't accidentally sort of close the window before you actually see the output. So here, this is a sort of very naive if-else situation where I could come in here and I could say console.writeLine, what is the first number, and then do var first equals console.readline console.writeLine what is the second number and so then we want to console.write line first. We would want to do something like first dot second. But if we run that code, what's going to happen? We're going to have, I would like a 1, my first number is 67, my second number is 4, and now I get 674. And the reason, again, is because console.readline is actually returning to us a string and not an int. So this kind of starts giving you the feel for conditional statements. These things work exactly the same way as you would expect them to work. And it gives you an idea of how console input and console output work. So this is an out stream, effectively this is an input stream. So what we can do now is start being ever slightly more clever. So we clearly are going to need first and second numbers for each of these operations except for the square root. We also have a bug here where I've copy and pasted code, so we need to update this stuff. So what we probably could do is we could have this block of code not replicated a million times, and instead we could do something like if selected op dot equals a 5, then we would do console.writeLine what is the number. So we only need one number in order to do a square root. We would do something like var number equals console.readline and then console.writeLine, and we're going to have to figure out what to do with this casting situation in just a moment. Then we would have an else statement where we know that unless we are doing square root, we're going to have to do 2 numbers, and so then that kind of eliminates the need for this else if. So if I have a 5, that means I'm going to do square root. That means I'm only going to need one number, so I'm going to collect that one number. Otherwise, I'm going to have more than one number, and I have to have 2 of them. And so if I need 2 of them, then I'm going to go into this code path. And in this code path, I'm going to simply return the appropriate operation for those first and second numbers. And so we do console.writeLine first, and 2 is subtraction, I believe. Yes, so first minus second. This is where we're probably going to start getting errors. So then console.writeLine 3 is multiplication, so we're going to have first times second, then console.writeLine first divided by second, and then else.writeLine. I don't know how to do that. Okay, so here what we actually need is we need the square root, so we can do something like math.square root of the number. It should give us, again, a kind of nasty squiggle, so great. So in an ideal world, if we have first and second or number in the correct data type, then a lot of our work is sort of already done, everybody's happy. So That is not the case. So if we come down here and we look at why the squiggle exists, is it says the operator cannot be applied to operands of type string, and so we recognize that we need to do something with this. So the kind of extremely naive way of doing this is to do something like double dot parse around each of these things. And this is gonna, again here, you see this is kind of shadowy, a little ghostly font. And so if you hover over and you go here, it says you can simplify this. So the uppercase is the type double, like the actual class double. The lowercase is the primitive type double. And so it is saying that that's a simpler name, so that's fine, whatever. And here we could do the same, double dot parse. And so now all of our squiggles should go away. Excellent. And so I can save this. I can start it. And now I have my console application again. So here I can go to subtraction, for instance. I can say 54. My second one is going to be 9. And now 45. I get a thing that is completely reasonable, and everybody's sort of happy. So that's all fine and good. But what happens if I do something kind of crazy? So if I say I want to multiply 4, and I want to multiply that by dog. Now I get this horrible exception over here, and the exception is sort of explicit. It says the input string was not in the correct format. And the reason is because I just tried to parse the word dog into a double, which obviously is not allowed. So we can handle this significantly better. So how are we going to do it? There is a library method called tryparse that we can use. So you can do double dot tryparse. And if you look here, tryparse requires a string, and it requires a double that is given this keyword out. What that out means is that the value is going to be passed back to this variable after this method actually ends. So here, what I can do is I can pass the read line as this first parameter. I can set up a double first, and I can give this a first. And I can say if out. And then do the next bit. So I can say console.writeLine the value or answer, and then add that to first. Well, we can't do them both at the same time. So what we're going to do is we're going to tryparse this thing. So what tryparse does is if this is successful, this will return a true. And so we'll go into this if statement. So then we will try to pick up the second number. So in here, we will do exactly the same thing. So we'll say if double dot tryparse my next bit of user input, and out second, type out second. And up here, then I can say console.write line answer first plus second. Okay, so there's quite a bit going on in here, so we're going to kind of take a step back and explain. So the first thing is we have now set up our first and our second variable to be explicitly of type double. I didn't have to necessarily do that. I could just as easily make both of these vars. Var. I just did it explicitly because I could. And if you see this, it is saying that in this case, Visual Studio thinks it's better to use the explicit case or the explicit type name. It doesn't actually really matter in terms of usable code. And what this lowercase d means is that this is a double literal. So if a 0.0 without a d is actually a decimal, a 0.0 with a d is a double. So I have these two variables set up here. These are going to serve as where I'm going to put the user input after it's been parsed into a double from a string. So what I'm going to first do is I'm going to ask the user for the first number. The first number is going to go into the try parse method. If it is successful, we're going to go into the if clause, or if into the if body. And at that point, this first variable is going to be set to whatever the user put in, and it's going to be in double form. We're going to do exactly the same thing with the second number. So here I have my second variable as the out parameter here. And when I get down to here, I'm going to have, well, my answer, first plus second. Everybody's going to be happy. If either of these things fails, right now, nothing will happen. If we add an else statement, console.write line, sorry, this second number wasn't a number. And down here, we do the same thing. Else console.write line, sorry, the first number wasn't a number. So what we have here is I am sort of implicitly doing the addition up here while I'm parsing. And so that isn't super great, but it kind of serves the purpose of showing how try-parse works. So double.try-parse, what it's doing is it's giving me a Boolean flag back that tells me if the parse was successful or not, and if it was successful, it is giving me the actual value down here. So what we need to do now is we need to take this out and put it down here, because that is where the user has actually chosen choice 1. So that is addition up here. We're asking them right here what they're asking us to do. 1 is addition. So here we are. And so now we're going to take this situation, and we're going to copy that into each of these. And so this second one is going to be a minus. The third one is going to be a multiplication. The fourth one is going to be a division. And we have already dealt with the fifth option up here, which is square root. Okay. So right now we have still not really handled the exception correctly, because what can happen is we have an if statement up here that is empty, and an else statement that only has a console.writeLine statement. So effectively what will happen is the user will get greeted with this sorry, the second number wasn't a number message, and then the application will still crash. It'll still come down here and try to add two things that are not correct. So in order to get through that, what we should do is in here, we should just add a return statement. So what this is going to do is if we add a console.read line and a console.read, and these can be read or read line. These are basically just artificial to keep the environment from closing the terminal window. But now what we've done is we've said if both of my if statements are okay, so if this if statement and this if statement is okay, do nothing. We don't actually want to stop the program from operating. If either of them fail, so if the second number isn't a number or if the first number isn't a number, go ahead and return, and then we won't ever get down here into the part of the code where we'll actually crash if we're trying to do something weird with strings that we can't, so something like subtraction or multiplication. So if we run this dude up, we should see something very similar to what we had, but now we can do 5, and I can give it 9, and it'll give me 3. Great, I can do something like, what is the square root of Cactus? And, oh, I didn't put it there. I only put it in the other ones. That's embarrassing. So here I would need to do the exact same thing. So I would need to say if the double.try parse is console.read line, out can be number, and here I would just make this thing a 0.0. And if that is okay, then we will do our actual math. And if it is not okay, we'll give the user an error message, and we will do the same console.read line and a return. So now, if I go back and I say I want to take the square root of a cactus, I can't take the square root of something that isn't a number, and then it allows me to be a dummy kind of without crashing or being kind of ugly. So, this is all well and good. This will allow us to do kind of rudimentary addition, subtraction, multiplication, division. It's sort of hokey. We're not doing anything crazy like operator overrides or anything like that. It's really just kind of to illustrate how if and else statements work, how things like try parse works. This is something that will come up over and over and over again until we can get to the server-side code part of the class. So you have to remember that everything that's read in from the terminal comes in as a string, but every primitive type has this try parse method on it, and each of those try parse methods work exactly the same way. So you'll have something like out whatever data type you want. The try parse method will return a boolean, and then if that boolean is true, you will also have the value that you expect in your out parameter here. So another thing that we might want a person to be able to do is something like continue to do calculations until they're sick of doing calculations. So if we provide an exit, we can do something like while 1, while true, this infinite loop situation, and put this whole thing inside of an infinite loop. here, so one of the nice things that you can do actually is do something like this. So every time you have a code block, these squares over to the left-hand side will let you collapse them. I'm not, I don't really want this to be here. I think it's going to make the input weird. So basically what I've got now is I've got an infinite loop around my whole program. And what this is going to do is let the user continuously do whatever they want until they type 6. So what we can do is we can say if this thing is equal to 5, great. If selected op dot equals 6, we're going to do console dot write line thanks, and then return, or then break. So the break and the continue keywords do exactly what you expect them to do based on experience you might have with Java or with C++. Here, what we've done is we have an if and then another if. This doesn't really make sense. We can make this mutually exclusive by doing an else if here instead of 2 ifs. And then we can kind of make this nicer here. I don't really know why, but I prefer this formatting. And now what I have is the 6 will break, 5 will take us into the square root situation. Instead of a return here, what's probably best is to continue. Here again, what's probably best is to continue, so the user just basically starts over again instead of returning out of the entire program. That would be a little jarring, I think. So that should pretty much do it. So we start this. I can do subtraction. What's the first number? 6. What's the second number? 4. The answer is 2. Great. I start over from the beginning. So now I can do division. What's the first number? 64 and 5. I get 12.8. It's fantastic. What about the square root? What is the number? 29. I get some crazy number. Perfect. And so it's continuing to sort of go through, and then if I press exit, it ends and everybody's happy. So note, you don't really get to see this gratuitous text. The reason is because we don't have a console.read line way out here. You could put console.readline after everything else in the main method. So if you look at this dude, basically if you put a console dot read line right here, and you do the whole thing again, you see that if you exit, you get the thanks, and then you click to make the window go away. That's extremely cosmetic, kind of little consequence. So a couple of other things that may or may not make sense. So why have we used dot equals here instead of the equals thing? So the reason I've used dot equals is the sort of comparison best practice for a string. So if you want to compare a string to another string because of the way the strings are stored, it's very similar to Java. You want to use dot equals to make sure that you're doing an actual comparison and not a reference comparison. There are overrides to this equals method, so you can do comma and then a space, and we'll show you all of the comparison types. So if we do string comparison dot, you will see that there are a crazy number of different options here. And so if you are in our case, this thing is an ordinal. So we can do ordinal and ignore case, and then it is going to compare strings of numbers to strings of numbers. Ordinal ignore case can be used for something like a GUID that might have hexadecimal values in it, and so what will happen is it won't care if the F in your hexadecimal value is capital or not. It doesn't really matter then. What I often use is invariant culture ignore case. That's if a person is using an alphabet or a keyboard that's entirely different from yours. It will not care about the cultural differences in the strings. It will also not care about the case. You could also just use invariant culture if you care about the case. And specifying if you care about the case and the culture is a best practice, because otherwise a person who's reading your code afterward may not have a clue what the ramifications are if they are passed sort of incorrect information or unexpected information. We could always just replace this with ordinal ignore case, and everything would stay exactly the same. So the reason why we're doing this, though, is our selected operation currently is a string. So just like we did before, we could always do var selected op equals 0. This is going to make selected op an int, and so then we could do something like if not int dot try parse out selected op. And then we could do a console, a console dot write line and then missing a parentheses, do a continue here. And then down here, you'll notice that this is now triggering an error. And the reason it's triggering an error is because this thing is now an integer, and integer.equals is very confused about why you're trying to compare it to a string type. So if you wanted to compare it to just an integer, you could do that if you want. Or you could do equals 6, and then that is a much more reasonable way of doing things. So we could change all of these to selected op equals 5, and then the else's, then selected op is 1, selected op is 2, selected op is 3, selected op 4, so on and so forth. And now if we run that up, we say subtraction, what is the first number? 6, what is the first number? 5, great. And it does exactly the same thing, except now we're actually taking the first user input, casting that into an integer, and then using integer comparison to walk through the menu instead of the dot equals syntax that's used for strings. One last little bit is a fairly new feature in C#, and we're going to go over it in a little bit more detail, not next week, but the next week. But it's quite nice. It's called string interpolation, and it begins with a $sign. So if you see a string with a $sign in front of it, what that means is you can use curly braces inside of the string to do concatenation automatically. So instead of having this kind of cumbersome string like that, we could just as easily embed this operation inside of the string using what's called string interpolation. So this is the string interpolation sort of operator or sort of key symbol. And you can do it anytime you're working on a string that isn't a string literal. So you can get rid of this stuff. You can get rid of this stuff. And so now, notice I don't have the $sign, so this is just a string. if I put the $, now it suddenly understands that I want it to actually perform the operation and then put the operation into the string. And so here, we do that. Excellent. So now I can start this thing up. I can go back to division, for example, give it a 12, give it a 3, it gives me a 4 back, everybody's happy. And then I can do exit. Perfect. So this is as close to procedural as C# kind of gets. You notice that I have a class that's called program. I have one static void main method. It looks very, very similar, if not identical, to a Java sort of main class or main method. So the next thing that we kind of want to do is talk about methods, or talk about how methods interact with this whole thing. So again, you can use the squares over here to collapse things. And so if I collapse that down, I can make a brand new method, and let's call this thing a static method. We're going to call it addition. Give me two, it's going to return an int first and int second. And so what's going to happen is it's going to return first plus second, and that's going to be that. And so notice before it was telling me that I wasn't returning a value. Now that I'm returning a value, I am returning a value, so it's fine. So now in here, instead of this, I can always call addition and then pass first and second. In this case, it doesn't really do a whole lot. Oh, I've called them ints down here, so I can do double and double and double. It doesn't do a whole lot, but it kind of does show you that in the programming assignment that you have due next week, you can encapsulate using methods exactly the same way that you would do with Java or with C++. I can have methods here. The reason why this is static is because the caller is static. So in order to call a non-static method from this static method, I would have to actually create an additional class, and that's something that we'll go through in another code along next week. So for the time being, just recognize that methods work exactly the same way that you would expect them to work. If you're calling a static method, in order to call a non-static method within a static method, you kind of have to have an object instance, and in order to have an object instance, I would have to create a class to have an object from. So basically, this is the long and short of the sort of very basic rudimentary syntax stuff. We've showed a while loop. A for loop would work exactly the same way. You can have a for loop that was also an infinite loop and break out of it the same way. Continue works the same way as you would expect it. The if, the else if, and the else statements work exactly the same way. There is some weird stuff around how to compare strings. There's some weird stuff around these literals with the lowercase d. And string interpolation is probably a new thing. Outside of that, everything else is probably very familiar, and you're probably kind of bored. So I'm going to stop it there. But going forward, like I said, what we're going to do is we're going to do way more complicated stuff. I just need to make sure that everybody's kind of up to speed. So the goal of the first programming assignment is to get you to do something that's very, very similar to the code that we just wrote. It's slightly more complicated because you have to do things like calculate sales tax. This shell that I have right here is a lot of the first programming assignment. The goal of that programming assignment is to make sure that everybody can actually compile C# and get a runnable sort of piece of code out of it. I suspect that the first programming assignment will maybe take you an hour, maybe an hour and a half, something like that, if you're really being pedantic about it. I would not necessarily stress out all that much about it, but use it as an example or use it as an exercise to make sure that your development environment is working. And if you have any problems or if you run into weird errors that you can't figure out, please send me an email and I'm happy to help you sort those out. So again, in order to get the best response time, please email me at crmills, mills, at fsu.edu. That's the one that goes to my phone, and I should be able to get back to you fairly quickly. Thanks a lot for watching and for keeping up, and I hope to see you next time. Thanks.